We have all seen movies in which characters travel to the future or past by traveling faster than light. But does this thing have any weightage in real life? Well, let's figure it out. Welcome to another video of Cosmos Observer, the only destination for your space curiosities. Faster than light communication or travel violates a fundamental principle of physics, something that is frequently overlooked in science fiction and difficult to comprehend for non-physicists. In a nutshell, permitting faster than light movement and communication destroys causality, and when causality breaks, time travel is possible. The universe is requesting that we choose two of these three options: causality, reality, or FTL. By choosing relativity and causality, the cosmos has already made our decision for us. This is why it is incumbent upon us to discover a method of traveling faster than light, but will we ever succeed? We won't, according to Dr. Stephen Hawking. According to Albert Einstein, the cosmos is mostly made up of space and time, or space-time. We can't even draw 3 dimensions on a 2-dimensional screen, but that shouldn't stop us from grasping space and time. So let's just eliminate all spatial dimensions and draw the entire T as a line. Because of relativity, if we are motionless on the spaceline, time will flow forward or orthogonal to the space direction surrounding us. The unique feature of relativity is that everyone calculates the speed of light in the same way. They can be depicted in a space-time diagram by stating that all space-time diagrams have light traveling at 45 degrees relative to the time axis on null lines, as shown in the diagram. Let's imagine 2 null lines of light are emitted from an event that occurred right now, and we'll refer to this as t = 0 for the rest of it. Despite the fact that space is aligned in the figure, it still has all of the space dimensions, and these rays of light are genuinely emitting in a sphere around us. Because light bends at a 45-degree angle, anything slower than light is closer to the time axis than the light axis, while anything quicker than light is further away. Let's imagine we have a built-in FTL communication equipment on Earth that allows us to communicate with the residents of the planet Proxima Centauri b, which is 4.25 light-years away. Remember that our location on the spaceline and the location of the Proxima Centauri people are both relative. So let me make another point for them that is different from ours. Proxima Centauri is moving at nearly the same speed as Earth. The variations are minor in comparison to the speed of light. As a result, no major relativistic events occur between our timekeeping and the proximal centurions. Let us now pretend that an event occurs far away from Earth, with the light from the event striking us before it reaches Proxima Centauri. This is how the space-time diagram for it might look. The light is initially seen, then it reaches Proxima Centauri. The light rays from the event move at a 45-degree angle to the Earth's temporal axis. After all, light moves at a 45-degree angle on space-time diagrams. Let's now add in FTL communication, where we view the happenings on the FTL phone and inform the nearby centurions. They receive the summons right away and have years to prepare for the advent of the light from whichever source. Let's pretend there's a massive laser traveling at the speed of light, obliterating everything in its path, and by chance it's heading straight towards Proxima Centauri's home planet. The diagram for that would look like this. Do you see the problem now that FTL communication has been added to the equation? We're all in agreement that the event occurred first. The light then reaches Proxima Centauri when the Earth calls it. Even though the proximal centurions hear about the event early, everything appears to be sugar and sweet there. After all, don't we all agree on what happened first? The effect is known before the cause. However, this graphic simply shows causality and FTL. Remember how the laws of the universe require us to pick between 2 of 3 principles earlier in this video? We definitely chose causality and FTL from the 3 options shown in this illustration. However, the cosmos has already decided to adhere to causality and relativity. So something is wrong and we need to repair it. The timeline in the diagram only works when everyone, including Proxima Centauri and us, is traveling in the same frame of reference. Add a new observer moving at high speeds relative to the Earth and Proxima Centauri to notice the problem. Consider a spaceship traveling at the speed of light. Now the relativistic effect begins to take effect. According to relativity, someone traveling at a constant velocity is perfectly justified in claiming to be stationary. So suppose we ignore the Earth's revolving around the Sun and the Sun's movement with the rest of the galaxy for a while. In that case, we may claim the planet is stationary and similarly, Proxima Centauri is stationary. However, neither the Proxima Centauri nor we are traveling at the speed of light, but the spaceship is traveling at the speed of light. However, they are at rest as well, and if they draw their own space-time diagram with their own axis, their time axis will match the ship's course. They also have access to space just like we do. Because relativity mingles space and time, their space axis, like their time axis, is distorted for us. The space axis has flipped across the 45-degree null line as it turns out. Relativity requires this strange blend of space and time of observers that we see as moving. So now what? Let's see what happens when the spaceship witnesses the event shown in this diagram. To do so, we'll need to know the ship's line of constant time, which isn't too difficult to figure out. Our lines in the space-time diagram parallel to the space axis are our lines of constant time. For the spaceship, their line for constant time will look like this. Let's review the events from earlier. We saw the space laser pass by us on its way to attack Proxima Centauri, so we phoned them on their lone FTL phone, and the Proximal Centurions did whatever they needed to do in response to the call. Then they saw the brightness of the event. However, things will be different on the ship. According to the diagram, they would see the phone call received on Proxima Centauri, then the phone call placed from Earth. Because consequence follows cause, causality is broken. Now consider this before you say that light travels in a finite amount of time and that a spaceship may view events unfolding instantly. You're forgetting that the light from the phone call reception arrives far earlier than the light from the phone call placement. Despite the fact that causality would be broken, a starship traveling faster than light is traveling in time and so has the ability to cause time paradoxes. Under relativity, whether certain events occur simultaneously is no longer an absolute thing but a relative one. If we plot points on a graph in which B is in the center and stationary, then A, B, and C all happen simultaneously. But if B is moving toward C, then the simultaneity of B is lifted upward, leaving C in its past. And if B is moving toward A, then it's the other way around, and C is now B's future. This is why in our tiny hypothesis, the spaceship witnesses the Proxima Centauri occurrence and receives the warning call before the Earth does. They now have data that can be used to change the course of events. They can either intercept a call made by Earth or prevent it from being made in the first place. Not only will this break time, but it may also break the cosmos. This is why the universe has implemented a safeguard. We can go faster than the speed limit in fundamental physics. Future societies will have stringent prohibitions against meddling with history. The notion that such taboos would persist in all communities till the end of time appears to be unsustainable. Since FTL is also time travel, the same finding would seem to rule out the majority of its variations. Because every law is broken by someone, it doesn't seem reasonable to expect the laws of time and causality to be any different. Suppose the means to break them exist at any point in the future. Only Stargate and wormholes that need the construction of a destination version may be able to circumvent this problem. However, word holes would have their own set of issues. Like the creation of them would require an extreme amount of mass and energy, but let's keep that for another video.